In lesson 2, we're going to be studying the wave equation, and we're going to figure out how to use it to solve for different things like frequency and wavelength. So our wavelength equation is usually this. Velocity is equal to frequency, which is measured in hertz, and wavelength measured in meters. But because we're studying electromagnetic radiation, which includes visible light, we know that all of the EMR spectrum travels at the speed of light. So we can use this equation instead. C, which is the thing that we use for the constant of the speed of light, which is always 3.0 times 10 to the 8 meters per second. And we know that all of our EMR is going to be traveling at that speed. So we're always going to use this version of the equation instead of that one. So the very first practice problem says determine the wavelength of the EMR emitted by a 60 Hz AC transmission line. So to solve this question, remember that we're looking for wavelength and we are given a frequency of 60 Hz. So I always like to start off the question by writing out the information that I have. Okay, and remember I'm going to be looking for wavelength, and my little c in my formula is always going to be 3.00 times 10 to the 8 meters per second. So my formula is this, frequency times wavelength. I'm looking for wavelength. So in order to do that, I have to put my frequency onto the other side by dividing it on both sides. So I'll be left with my speed of light divided by my frequency. So my speed of light, remember, is 3.00 times 10 to the 8 meters per second. I'm going to divide that by 60. And I'm going to type these numbers into my calculator. So in order to do this easily, I have to use my second function e button instead of saying times 10 to the 8. I ended up getting this as my answer, okay, which is a really big number, 5 million meters. So I'm going to just put this into scientific notation. So I'm going to say 1.0 times 10 to the, and figure out how many times I have to move over. So I counted 6. So that's where my scientific notation comes from. And I circle my answer. So practice question 2 is talking about a cell phone, and it uses a frequency of 800 megahertz. So this time I'm looking for wavelength again, but I'll have to do some work to this megahertz in order to deal with it. So again, I'm going to write down all of the information that I have given. My frequency is 800 megahertz. I can't use megahertz. I'm going to have to change that into hertz. In order to do that, I have to always set up a fraction for myself. So I'm going to write down my information. I'm going to put a fraction beside it in brackets. I'm going to put megahertz on the bottom because I want to get rid of them. And I know megahertz is the bigger unit, so I'm going to put 1 next to it. In 1 megahertz, I have 1 million hertz. So that shows me that I have to multiply the numbers together. So I'm going to go 800 times 1 million, and that gives me this number, 800 million hertz. So now that I have that conversion done, I can actually go through and solve for my answer. So my formula, I'm looking for wavelength, so I'm going to look at the speed of light is equal to frequency times wavelength. I'm going to divide by frequency on both sides to get rid of it, so that I'm left with wavelength by itself. And then I'm left with my speed of light divided by my frequency. So remember, speed of light is always 3.00 times 10 to the 8 meters per second. And I'm going to divide that by my new frequency that I just found by converting it. So 800 million hertz. And then I'm going to divide my numbers in my calculator. And that gave me 0.375. And the answer is in meters because I'm looking for wavelength. So practice question number 3. This time I'm going to be solving for frequency, and I'm given a wavelength of 390 meters. So again, I'm going to start off by writing what I have. So my wavelength is 390 meters. This time I'm looking for frequency, so my formula will look slightly different when I solve for it. This time I'm going to divide by wavelength on both sides to get rid of it, so that I am left over with just frequency all by itself. I'm going to rewrite my formula so it looks nice. Then I have 3.00 times 10 to the 8 because that's always my constant for the speed of light. I'm going to divide that by my 390 meters, and I'm going to be left with hertz, which is my frequency. So 3.0 times 10 to the 8 divided by 390, got 769,230.7692. It's a big number, so I'm going to put it into scientific notation. So I'll say 7.69 times 10 to the 1, 2, 3, 4, 5 meters. Oh, and look at me go, I'm making mistakes. The unit should be hertz here, not meters. I made a mistake. Okay, so the last question here is looking at a radio station. So the actual number that you see on your dial when you put radio stations on for FM is in megahertz. So for example, 102.1, like the radio station here, is actually 102.1 megahertz. So we're going to calculate the wavelength. So basically how long are the radio waves that are being sent from that specific radio station. So when I do this, just like any of the other questions, I'm going to write down my information. I have a frequency. So I have 102.1 megahertz. Remember, I can't use megahertz. I have to get rid of that and make it into hertz. So I'm going to put megahertz on the bottom because it will then cancel out. Hertz is on the top. Megahertz has 1 because it's the bigger unit. And in 1 megahertz, I have 1,000,000 hertz. So now in my calculator, I know I have to multiply the numbers together. So that gives me 102,100,000 hertz. And then I can calculate from my wavelength to see how long the waves are actually coming from 102.1. So remember, my original formula is speed of light is equal to frequency times wavelength. I'm going to divide by frequency on both sides, cancel it out, and wavelength will be by itself now. So I'm going to divide my 3.00 times 10 to the 8 meters per second. Divide that by my new number of hertz, 102,100,000 hertz. I'm going to put that into my calculator. Doing it the fancy way so I don't make any mistakes. Making sure that I have the right number of zeros, and I got 2.938, and I'll just leave it at that, and we're doing wavelength, so it should be meters.